Hi, and welcome to this video. In this video, we will implement text cleaning in Python. Consider a text. It is raining heavily today and I am not sure if I will be able to travel. Can we postpone our meeting? Hope it is fine with you. Emoji. I am sending a new meeting invite on this link, which is embedded in a anchor tag. You may assume that this is the text which we have obtained from web scraping of some email related data or a website. That's why some anchor tags, some emoticons, and some additional noises are present in this text. What are those noises? Those noises can be variations of lower casing, proper casing, or upper casing. The emoticons which are present, the presence of HTML entities or HTML tags, presence of stop words, presence of punctuations, and some unnormalized keywords as such. So to perform text cleaning, first step we should do is to lowercase all the text, which we can easily do by calling the text.lower function. Now if we run this cell, all of our text will be converted to lowercasing. Next, we should remove these anchor tags or any other HTML tag which is present in our text data. To do that, we can make use of regular expressions. If we use re.sub function and pass a pattern which can just replace these HTML entities, so these HTML entities can be removed. So we can define that regular expression pattern as less than greater than. Inside this less than greater than, we will define our regular expression pattern, which will be something like this. Now if we collect our new text, we will see that whatever which was present in less than or greater than symbols will be removed. So as we can see, the anchor tags have been removed. As the next step, we can remove punctuations from this text. To remove punctuation, we can import string. We can define all the punctuations which are present using string.punctuations, and then we can just say our new text, punctuation free text, should be all the characters of our text. Let's say character for all the characters in our text if those characters are not present in punctuation. So now if we wrap this particular statement and if we join them using dot join without using any delimiter, this will give us our new text, which will be punctuation. So as you can see, all the punctuations have been removed. Notice that this slash n is not actually a punctuation, it represents a presence of new line character. We can explicitly remove the slash n by making use of replace. So inside replace, we will say we want to replace slash n with, let's say, empty space. So now those slash n's have also been removed. Additionally, what we can do is we can now remove stop words. To remove stop words, we can make use of NLTK package. From NLTK package, we can first of all import the list of all the stop words which we want, and NLTK provides stop words in different languages. So we can, let's say, define our stop word list as stop words dot words of English language. Now to remove the stop words from our text, we can iterate by word in our text by splitting the text into words using text.split. And while iterating, we can just check if our word is present in stop word. If that word is present in stop word, we will just do nothing and we will just pass this statement. And in else condition, we can define, let's say, a new word or a new text list, which will be a string. It starts with empty character, and we can say text cleaned plus equals to word, which basically means that we are adding all those words which are not stop words. So in the end, if I just print this text cleaned, we will see that all the stop words are removed. But one thing we can notice here, that all the words have been concatenated together. This is because while adding every new word, we did not added any space. So a good thing will be if we can just also add a space before adding any new word. Now we can see that all our words are stop word free, and we have basically removed punctuation, stop words, all are lowercase, etc. As the last step, we can also perform lemmatization in order to remove inflectional forms present in the words. Because it is possible that, let's say, this raining was present, rains, rained, etc. These variations were also present. So context of raining was same, which was rain, but different variations were present. Again, to perform lemmatization, we can use NLTK. From nltk.stem import wordnet lemmatizer. We can define our lemmatizer object as wordnet lemmatizer. And now to perform lemmatization on every word, we can again split split our text into different words. And what we will just say is that our new word is the lemmatized version of the previous word. We will call lemmatize function. And we can again define our new text clean one, which was an empty string. And now we will just basically say we will first add a space, and then we can add our new lemmatized word to this text clean. In the end, we can print this text cleaned one. Also notice that in the previous cell we converted our text to text cleaned. In this cell we should use text clean. Okay, so here we are getting an error which states that lemmatize is not defined, so it should be lemmatize. Yeah, so now it is performing lemmatization on every word, and so as we notice that none of the word is converted, this is probably due to we haven't defined the part of speech tag. And yes, now if we define part of speech tag is equals to verb, now we can see that raining is converted to rain, and meeting is converted to meet, sending is converted to send. So in the end, this is our final cleaned text. As the last step, we can just call dot strip function, which will just get rid of spaces which are present in the end. So this is our clean text, which we can now use for feature engineering, text classification, and any other natural language processing task. Thank you.